Here Clois Thermal पे सही सिंह पश्चिमी अफ्रीकी रेंडिनेवियन लियोनी channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is methods of measurement and error analysis. Let's begin. Systematic errors genuinely arise from a consistent, repeatable flaw. Like an instrument's own zero error or a flawed experimental technique, these genuinely push every single reading in the same direction, and can actually be corrected once identified. Random errors instead genuinely arise from unpredictable fluctuations, like tiny variations in a human observer's own reaction time. These genuinely scatter readings randomly both above and below the true value, and can only actually be reduced by taking multiple readings and averaging them together. Absolute error delta A is genuinely the difference between one specific measurement and the relative error genuinely expresses that absolute error as a fraction of the mean value itself, delta A over a mean. This genuinely provides a far more meaningful sense of a measurement's actual quality than the raw absolute error alone, since an absolute error of 1 centimeter genuinely matters enormously for a small object, but is utterly negligible for measuring a building. Multiplying that relative error by 100 genuinely gives the percentage error instead. This specific percentage form is genuinely the standard way experimental precision actually gets reported and compared. When quantities are added or subtracted, their absolute errors genuinely simply add together directly. Delta, or a plus b, equals delta A plus delta B. This holds true regardless of whether the original quantities were themselves added or subtracted. When quantities are multiplied or divided instead, it's genuinely their relative errors that add together. Delt, over polographiakite lacking Michel of Mercury quam patharoj equals delta A over A plus delta B over B. And when a quantity is raised to a power n, its relative error genuinely gets multiplied by that same power n times delta A over A. This power multiplication effect is especially sensitive to measurement error. Here Clois Thermpe acting Muk Parasine error propagation rule for each specific operation, absolute errors add for addition and subtraction, but relative errors add for multiplication and division. Mixing these two rules up is genuinely the single most common error made across this entire topic. A frequently tested trap involves genuinely a formula where a measured quantity is raised to a power, forgetting to multiply its relative error by that power genuinely gives a significantly underestimated final error. Also remember that when a quantity appears in the denominator of a formula, its relative error a satiail simply adds to the total equally like a numerator term. Subtraction in the original formula does not translate into subtraction of relative errors during propagation. Let's recap. Systematic errors are consistent and correctable, and are reduced by an relative error delta a mean, and percentage error give a more meaningful sense of measurement quality than absolute error alone. When propagating errors, absolute errors add for addition and subtraction, relative errors add for multiplication and division, and a power n multiplies the relative error by n. Applying the correct propagation rule for each operation is the key skill this topic tests. That's methods and error analysis. Keep the addition versus multiplication error propagation rules sharp. They're the fastest way to handle error analysis questions on the exam. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.